Hello again. Um, this talk it's called "Let's Give Rest a Rest," exploring the state of gRPC in Ruby. Um, First, let me introduce myself. I'm development team lead at ThoughtBot. It's a Ruby on Rails consultancy you might have heard about. Um, we've been in the market for 20 years, more or less. I'm from Guadalajara, Mexico, so that was like a long trip over here. Um, There in Mexico, I am the organizer of a Ruby meetup called Ruby MX, and the organizer and the host. So I'm really aware of how difficult and how exhausting it is to organize a conference. Even though my meetup is for 40 people, I can imagine how hard it is to organize this. So kudos to the organizers. It's been great. I'm also co-organizer at the Rails Reach Mexican chapter. If you have not heard about Rails Reach, it's an initiative to introduce people with low representation in the industry to start doing Ruby. And it was an odyssey to get here, so I took a bus and then a plane and then another plane and then another plane. So it was like close to 24 hours travel straight, but I made it and it's been worth. Let's start with the story. A long time ago, I joined a Ruby on Rails consultancy as a trainee in 2013 there in Mexico. In October 2016, I left that company to join a startup. And at that time, and I'm still in love with Ruby, but why? Why did I move companies? If I was doing Ruby, I was getting paid for doing what I love. The reason is the stack, and not the Ruby stack that I was using and I was familiar with, but the stack that I was going to work on. Remember, at this time, I had never worked in Go. I had never worked with Cassandra. I was using just Postgres. Kubernetes was kind of a brand new thing. I have never heard about that. Angular 2 was in beta. And we were using gRPC and protobuf. From this stack that was new to me, there was one specific part that caught my attention, which is gRPC and protobuf, which is what we're going to talk about today. Sadly, 5 months later, when I joined this company, I had to put my open to work banner. The startup life was not for me, but I learned a lot, so that was really cool. And in 2017, I joined another Ruby on Rails consultancy, and I've fortunate enough to been doing Ruby on Rails full time since then. So I really feel blessed about that one. When I came back to Ruby, I tried to bring this tool that I love a lot, which is gRPC and protobuf. And I tried to hey, this is a really cool tool. I think it has a lot of future. Let's implement this in Ruby. And I tried this with a couple of projects. There was a client that was implementing an MVP with microservices. Yep, that was not a good idea. But I tried to implement this, try to promote it, and I did have no luck at all. And the reason, or the reason that I want to give this talk is I want to explore, and I wanted to know why gRPC is more popular in some languages compared to others. And the first thing that came up to my mind is, okay, let's try to get some general idea about how popular it is. And I searched for gRPC Go, and I got more than 12 million records. And then I did the same for JavaScript, 4.4 million results. Let's try C, 6.7 million results. What about C#? 2 million, not bad. What about Ruby? Do you have any idea? How many? 100? Not a little bit more. Not even 500,000. So let's do another travel to the past, or let's move to 93, 94. About 93, 94, we have the popularization of the web. The first web page was created in August 1991 and was published a month later. The web started to get popular in 93, 94 when pages for general use were made available. At that time, there was only a fragmented description about the web architecture. And there was some pressure about setting a standard on the web interface that we were using. For example, some experimental extensions were already added to HTTP to support multiplexing and proxy servers, and there were more extensions proposed. But we didn't have a formal architecture, and it was needed. Um, then we had a couple of work groups for the W3C and the IETF, the Internet Engineering Task Force. They began to work on some formal descriptions for the three main components of the web, which is URI, HTTP, and HTML. And there was one person that you probably might hear about that person that was involved in the elaboration of the three standards, specifically HTTP1, HTTP 1.1, and URI. This person is Roy Fielding. And Roy Fielding, the following 6 years, from 1994 to 2000, he worked on the REST architecture, testing the restriction of the standards for the standards for the web that we already had, and he tried to use those standards and the limits to identify discrepancies and try to do some improvements on the architecture he was proposing. And in 2000, he came up with his PhD dissertation called Architectural Styles and the Design of Network-Based Software. The long story short is we have this diagram that you might have already seen in the past. REST is designed to work for network-based applications, specifically following the client-server pattern, which we still use a lot. And more than that, it was not just for local applications, it was designed for the scale of the web. So the coupling of client and server should be very flexible because we didn't have control about the clients. And he wanted to make the integration for web as accessible as possible for many people. This loose coupling and also that the communication was text-based using a uniform protocol set the foundation for the web requisites, which was independency, robustness, support language data transfer, and a low-level barrier for consumers, for content creators, and developers. Some of the relevant parts of this architecture that you might be already familiar is that it is a stateless client-server protocol. In theory, each HTTP request has all the information that it's needed to complete the request. In practice, we know that we store some state. We also have well-defined operations that can be applied to all resources, and HTTP defines these operations, the most common: post, get, put, and delete. Also, we have a universal syntax to identify the resources, and in a REST system, each resource can be redirected or can be directed uniquely by its URI. And we also count with hypermedia, which allows the navigation between these resources, and we can navigate from one resource to another. Let's do another travel now to the past again, but the future compared to 1994. So let's go to 2016, which was the microservices era. Specifically, in August 2016, Google released some technology, which is called gRPC, which is what brings us here. gRPC, it's a remote call procedure open source system that was initially designed by Google. It uses HTTP2 and uses protocol buffers for the language interface description. It provides features such as authentication, bidirectional transmission of data and flow control, blocking and no blocking bindings, and cancellations and timeouts. And one of the features that caught my attention the most is that it also offered, how can I say it, cross-platform code generation by default for many languages. The most common use case, as I mentioned at the time, was microservices, but also it found like some interesting niche in mobile web applications that needed to that wanted to connect to backend services. The idea is simple. We have servers and we have clients, and those servers communicate back and forth with the clients. The communication for this case always starts with the client. The server gives a response. That's pretty standard. And even though at the time gRPC was something relatively modern, It's in reality a new version of the RPC architecture. They offer support for several languages, including Ruby, C Sharp, Kotlin, Node, Java, .NET, Dart, and others. And there are third-party support for other languages not mentioned on that list. What is RPC? If you, for some unfortunate reason, had taken like a class or a course about distributed systems, I remember that I had to do this by scratch. I had to take care of communication between two machines, and one machine acts as the server and has some operations available, and the client automatically or automatically, they only had to do a call that seems to be local, but the internal or the code that we had to implement had to figure out how to find a service that accepts the call, then receive the data, process it, do the operation, return the data, pack it, and then the client would just use that as a regular local method. But in reality, it's not local. It's doing a call to external system. The idea behind RPC is that the service defines the interface about what are the operations that the system can perform. The characteristics of gRPC, again, the ones that really, the first time I worked with this was like, oh, this is really cool. I really need to do this in Ruby. Definition of services and contracts, which is what we mentioned, that a service already exposes, okay, these are the operations that I can do, this is the data that I need, this is the data that I'm going to return. And the way that gRPC implements it, it's through protocol buffers or protobuf, which is a binary format, also developed by Google at the time, that simplifies the storage and interchange of data between applications. This is language agnostic. This is how a prototype looks like. If you see, we have a declaration of the syntax. We can use a package. And then we have two main components. We have a service, in this case, a hello service. This service has only one operation. The operation say hello. This operation say hello, expect a hello request, and it's going to return a hello response. And if we see, we have two messages, the two messages mentioned before. We have a hello request that only has one attribute, a greeting, that is a string, and it takes the position number 1. We also have the hello response that has also one attribute, reply, and takes the position number 1. We have 4 types of method calls. The classic one, or the simple, which is what we do most of the time. A client sends a request to the server, it waits for a response, and the communication is done. For the example that we're going to see, this is the one that we're going to take a look, because it's the most simple, and it's the one that it's closer to a REST API, which is what we're comparing to. But also we have a server-side streaming, when the client sends a request, and then the server just gets a stream to read a sequence of message back. The client reads from the return stream until there are no more messages, and the communication is done. If you take a look, the difference is the word stream. Therein returns stream, hello response. Sorry. We also have the other way around. We have a client-side streaming, where the client writes a sequence of messages and sends them to the server, against using a provided stream. Once the client has finished writing the messages, it waits for the server to complete the response, returns the response, and we're done. Or we have one of the interesting ones, bidirectional streaming, which is pretty much a combination of the previous two. Both sides send a sequence of messages using a read-write stream. The two operate independently, so each client and server can read and write in whatever order they want. One example, they could wait. The server could wait for all the messages before writing the messages back, or could like do an alternation. Okay, if I the server get a message from the client, it returns a response, and then the client can do this again, or any other combination that we want. Again, let's see some Ruby. There's a demo. You can take a look at that URL. I'm going to share that at the end, so you don't need to write that at this moment. As I mentioned, the interesting part is the definition of a contract. We're going to use the same contract that we're already familiar with. Pretty much it's a hello world with gRPC and protobuf. We have the hello service. Remember, we only have one operation available, say hello. We receive a hello request, and we return a hello response. Okay, we have the proto definition. What's next? We need to create our server. And one of the other characteristics that really caught my attention is that, as I mentioned, we have support for several languages, but we also have a tool for code generation based on the previous proto definition. So one example for this example in Ruby, this is how we generate some code based on that proto definition, where we have a tool. Once we install gRPC and protobuf in our machines, it will be available. So pretty much we specify what is the folder for the protos, where we want the output, and what is the proto that we're going to generate code from, which in this case it's hello.proto. This is going to generate two files. We have a PB file. Again, we have a descriptor data that it's going to be used to identify the service. And also the interesting part is that module. If you see, it has two definitions, a hello request and a hello response, which is exactly what we define in our proto. And another file, we have a service file. This is the base. This is the file that we're going to use to implement the operations for our service. Again, the relevant part, this is boilerplate that it's generated, so we don't really need to get into the details. The tool exports the marshalling defaults for Marshall and Marshall. In this case, we're going to use encode and decode. And the other interesting part is, if you see, there's a stop that it's equal to service.rpc stop class. Okay, now we have these two generated files. What's next? Well, we need to implement our service. What we need to do is we need to inherit from that generated service, hello service in this case, and then we implement the methods that we promise that we're going to deliver. In this case, we only have one, say hello. What we receive as input is the hello request, and we receive the call. In this case, we only care about the request. What we're doing is, it's very simple. We're just putting some output to display the message that we're receiving, which is a hash. In this case, the way we can access the data, it's through hello request.greeting, which again, if we go back to our proto definition, this is what we said we have. We have a greeting. So we have the data available in that value. And okay. And then as a response, we just create a new response. We pass the data that we promised that we're going to pass. In this case, it's just one field, reply. And we're just doing a concatenation, like hello and the greeting that we already have. That's the client. That's the only thing we need for the client. gRPC already takes care of the packaging, takes care of the communication. We're done. To create our server, it's also very easy. In this case, where we have the gRPC part that it's going to do the communication, but we need to start that somehow. And the easiest way you can do it, you can define a port. In this case, we're going to run in the port 50051. It's kind of the standard, at least for testing. We create a new instance of the server. We tell the server to listen to this port, which is the one that we define. Also some logging, just to have some idea on what's going on. And then this is the critical part, server.handle. With this, we're telling, okay, you're a gRPC server, and you can handle the messages defined here. And then we just have like a way to terminate the program. Okay, now we have a server. What's next? We need to create our client. Again, we already have a proto. We can do code generation. It's exactly the same. Just for this case, I'm using a different folder to simulate that we're working on two different machines. In this case, it's client instead of server. but the output is exactly the same because we're using the same proto definition. And now we need to implement our client, which is also something kind of simple. Remember this stuff that we had in the generated file. We use it here. It's like, okay, we have an stuff, but this is where you are gonna find the services, the real ones. So we're just specifying that they should be available in localhost 50 or 51. And then we have another method that just says run say hello, and we send this stuff. If we see at the top, the method it's doing is just receiving the argument for command line argument. Or if we don't provide one, we use Euruko. Also some messaging just to see what's going on. And what we do is, okay, from the stuff we have, that this stuff already knows how to communicate with the real server. Let's call the same hello method. And we pass the request. We do a new instance of the request with the message that, again, we already agreed to, okay, we're going to send a message with the greeting value. And that's it. We get a reply as we promised in the proto, and we can use that. If you see, we don't have any visual clue that this is doing a call to a remote server instead of a local server. It's just like a regular method call. How we run these things, just like regular Ruby apps. We don't need to do anything particular. It's the way we run the server. Then how we make the client do a call to this method. In this case, just run the application and we pass the argument. This is pretty much the output. When we start the server, we get some, in this case, warnings. And when we run Ruby client and the message that we want to send, it's going to send the message to the remote server. The remote server receives the request and then responds, and the client just writes, hello, Euruko 2024. That's the end of the demo. What are the advantages of using these? Because even though we are not in the microservices era anymore, which glad we're not, there are some advantages and some cases where probably it can be useful for you to implement protocol buffers and gRPC instead of like a RESTful API. One of the issues, or one of the things that tries to solve it, we have seen this problem again and again, versioning. We change the contract for an API and we need to create a new version. And then we have version 1, version 2, version 3. The way that we can solve this with this technology, we don't have like proper versioning, but we take advantage of protobuf. For example, this message has three attributes. Has the attribute query in the position number 1, page number in 2, and results per page in 3. Let's say that we want to get rid of page number. Like, okay, we don't need page number. We're not going to return page number. The first thing that might come to our mind is, okay, I'm going to delete that field. But what's the problem? There might be some clients that depend on that field. So what do? We don't delete the fields. We just deprecate them. And we can just, okay, delete, and also mention like, hey, this number field, it's already reserved. Don't try to use it again, because that's also one of the problems that we might have. Okay, let's say that we remove the number 2. And then in the future, another developer says, okay, we're going to use number 2 for other thing. So then we have like, okay, no, you cannot do that because this is already reserved. It was used in the past. It's not used anymore. So you're not allowed to do that. This is interesting. It gets tricky when you have like hundreds and hundreds of fields. But it's a way that it's like, it's worth exploring. And it's something that we can try to mimic in our REST API. Instead of changing our responses, we can just like, okay, this field is deprecated, and now we have a new field that it's providing something different. Other advantage, definitely performance. Fernando, a couple of years ago, he discovered that an API with gRPC, it's definitely faster than a REST API, around 7 to 10 times faster. This is mainly due to HTTP2 and also the packing that protocol buffers implements. So we have like very lightweight messages. Disadvantages of using this technology? Well, first of all, definitely implementation. When you work with Ruby and you're probably working with Rails applications, maybe you are familiar with how to do Rails APIs, but if you get into this technology, there's a learning curve, and we should take that into consideration. It's definitely more complex. Also debugging, we're using binary messages, so trying to see what's wrong, it's harder than when we work with JSON requests and responses. When should we use gRPC? Well, it depends. I don't know you. I don't know what you're doing, so I cannot give you a specific advice. But some things to consider, definitely for proof of concepts. It's very good to implement something quickly. I think even for this example was faster for me to build the example and even more complex code that I have built for in the past. It's faster than building an API. I'm building the documentation for the API. I'm building testing and more stuff. So probably for quick communication proof of concepts, maybe it's a good option. And where it excels is for multi-language systems. If for some reason you have teams that need to work on different languages, let's give a try on this. As you see, generating the code and the boilerplate that it generates, it really speeds up the development process. And the other aspect where it shines is definitely microservices. It was the tool to use when you were building microservices with Go a long time ago. And other suggestion that I've seen that could work in your case, it's for internal communication systems. When you are not exposing a public API, probably it's worth doing something more. Okay, let's do a binary communication and let's do just gRPC instead of implementing a REST API for our internal systems. And also it's a very good option for low bandwidth networks. Why? Because the packages are way smaller than a JSON message. It's very good, let's say for IoT, it's definitely a good example, or it's a good implementation of this technology. And also, as one of your innovation tokens, I don't know if you have heard about this term. If you have not, I really recommend you to visit this page, boringtechnology.club, by Dan McKinley. I think it was like a presentation that he did, and then he transcribed the presentation to this page. Long story short is that he suggests that we should have 3 innovation tokens when we're building something, and we can use them for whatever we want. Do we want to use a new database? You spend 1. Do you want to use another front-end framework? You spend other. You only have 1. Where you want to spend this token on? Probably you can try. Again, you don't lose. The only thing you might lose is some time trying to see if this fits your needs, and if it doesn't, okay, just move over and try with, or go back to REST. So as a conclusion, and trying to give a response to my question, why is gRPC more popular in some languages than in others? I don't know. I mean, I don't have the exact answer, but I have some guesses that I want to discuss with you. The first one is that the gRPC and protobuf has really strong ties with microservices. So if you are not doing microservices, you're probably going to discard this technology because it doesn't fit your needs. The other is that REST APIs are enough most of the time, and more than enough. Definitely, REST is a very good architecture. We already are familiar with that architecture, and we know how to solve common problems in REST APIs. So most of the time, it's exactly what we need. REST is very good and it's mature, so no reason to change that most of the time. And the last point, or the conclusion is, in theory, yeah, it's very tempting to have a system that it's 7 or 10 times faster. That's exhausting. That's exciting. But speed is not everything, to be honest. There are more factors. As we mentioned, it's more complex to build, probably hard to maintain. Probably you're going to run issues that you are not familiar with, so you won't be able to solve them as effectively as with other technologies. And related to speed, one of the examples of the things that come to my mind is the proof that speed is not everything is that's why most of us don't go to work by plane. If we only care about the speed, why not taking a plane or like a bullet train? Because there are more things to consider, not only that. Um, thank you. That's all what I have for today. Um, just some upcoming ThoughtBot events, in-person office hours, October 10th and 11th in London. So if you're around, you can sign up to chat with the team. And we're organizing an ThoughtBot Open Summit when you will be able to collaborate with the ThoughtBot team on your first collaboration on our open source gems. That's going to be the 25th. Thank you.